Yeah, we should be live. Are we live? Yeah, and the phone lighting up. Give me a sec. Hit the link. The link to the stream. This on Twitter. And posted on LinkedIn as well. Give me a sec. Should be quicker. My voice is back, so I can actually talk. So that's nice. We'll start in a sec. So we got the share the screen, the stream link. So we get this new tool on bionicchaos.com. It's a particle motion simulation. Getting some ads in here. So I just move this into local server so you don't see the ads, and I can keep developing this thing. I just turned the server off. So this is it. There is some explanations at the bottom that you can check out. By the way, we also on. I'm also trying out the Discord. Just not sure. Um, not entirely sure how to actually use it. So I'm in my own channel created this stage. Yeah, don't want a stage. Probably should be enough with a voice channel. So yeah, so I can. And why? There's something wrong with the settings. Devices doesn't work. Um, yeah, not entirely sure. How to use this. Yeah, go figure. If anyone can help me with that, that would be awesome. Camera using If I use the OBS virtual camera, that's not running. I don't know why it's so normally reverses. Well, I can start it from here. I don't know. I see it on my screen. I see it mirrored, but hopefully it's okay on your screen. Anyway, not sure how this works. See myself speaking. I have the video shared, so it should be fine. Then people can join in, I would imagine. Obviously, you need the link to it. The same link that I used before. Not sure. That's the VW at the end. It's not the same link. Let's generate. Invite. Copy. Yeah, that's the Discord link in the chat if you want to join in live. In theory, yeah, I was using Zoom before, but yeah, Discord should be more interactive and having more options. Anyway, back to this. So this is development server. I mean, we have this running live as well, but this has ads on it. So we need to recover some electricity costs. And yeah, so this transcription works. And when people would tell me it not running on our browsers or certain conditions, so I know it's working well for me. Hopefully it works for another, at least one person. That would be great. It's transcribing okay. I'm still testing it, but yeah, feel free to test it as well and let me know what you think. And there is essentially description down the bottom. This was generated by the code interpreter, GPT-4. Let's get back. Yeah, we need to fix a couple more things. We have the particle motion. Same thing about the particle motion. There's a description of what's happening in here. Yeah, obviously this screen size, it's not very helpful. It's only probably once you get, I mean, you could make the particles bigger. Could have made a slider for the particle size and the number of particles, but yes, this is a model of some sort of particle activity. Hopefully the model is more or less real. When in the JavaScript you have the actual maps behind it, so it's pretty simple. Simple thingy. Wasn't behaving like this before. Yeah, there's some errors when it's touching each other. Should right change because there's a problem with this thing because there's a JavaScript that checks for it's behaving in a weird way, and I don't know how to fix that. Yeah, I had all sorts of trouble with it. Eventually, ChatGPT was able to sort something useful for us. But then I was changing the box size. It was the last change. And now it looks like they don't actually find. Oh no, they do. Yeah, so these two, when they go past the jar, yeah, these two now should actually interact. Which they do. Yeah, so these two just brushed off. These two should start. Yeah, that one changed direction. So it actually makes some sense. Yeah, number 500. It looks better. What screen? Right, every screen resize will restart the thing, which is not ideal. Anyway, you have some explanation there. And yeah, let me know what you think. Just double check. Yeah, the styling of it is a bit tricky because it has two CSS files, one for the whole body chaos site and the second one for this specific tool. So that only should affect the buttons there and the background and things like that. Is it still transcribing? No. Let's check any. There are two errors. Yeah, this error is something we generate ourselves, and it's meant to restart the thing, but it doesn't seem to actually do anything. Yeah, the other error is the Google ad that's again not to work because we're in development on the development server. Get back to the landing page. Those other tools are previous tools. They were actually not optimized. They were done in yeah, they do get errors and the like. This was done in a no-code environment by National Instruments, and it's actually generating this XML code, which from memory I was trying to rewrite. Yeah, I did rewrite bits into HTML, but this main thing would still be the original code, which is, yeah, it's not great. It's not ideal. So we will eventually be either redeveloping those tools or just making new ones. But they're still on the page. They're still working okay. They do mean, however, that I have to run another server that does the API that actually generates this data. But that's should be okay. Getting some errors for this. Yeah, let's see what else we've got. Right, another thing, we're trying to generate the faces using GAN and existing models. Didn't have much success with that, unfortunately, and that's mainly because TensorFlow is not supporting native Windows, which is unfortunate. So I had to install what's called a Windows for a Linux thing. It should be running okay. Oh, still have that thing running. So it's hard to arrange all the windows. So in here I can run TensorFlow in theory. The new TensorFlow is not supported on Windows, but then it's still not set up correctly. I'll go back to my Windows thing. This is just Windows development. Yeah, we couldn't get the faces to run over here. Yeah, all sorts of errors. Right, so we could run it in PyTorch. Which one was the image generation? Image gen. What was the last file? Next frame. Right, so this one's using TensorFlow again. Wasn't running. Right, this one's actually training. Right, so this is not a face generation. This is like a moving circle on screen. So essentially should be something similar to that. And this is actually training a model that predicts the next image. from this. Oops. Let's just do. Let's stop the training. Anyway, because it's using TensorFlow, it doesn't work on my machine unless I set up that WSL to the Windows for Linux thing. Then hopefully it will start working again. Having trouble with the size of this. Yeah, because it's always a square window, which is not ideal. So we'll leave the TensorFlow wouldn't work. Unless should we move it to the Linux kernel? See if we can get anything useful out of it. This should be predicting a next image. So essentially, if you give it something like that, it will try and. So it's training. It's actually training a model from scratch, trying to predict what the next image should be. That's still using TensorFlow. So it's either I'm using a PyTorch and staying on Windows, or moving to TensorFlow on Linux. Um, yeah, the TensorFlow on Linux will start complaining that I don't have certain. Oh, come on. Right. So this thing, if I start, this one has a different Python version as well as a 3.10. So Windows I have 3.8 and 3.11, and on Linux I have 3.10. I don't remember how. I don't think that was a conscious decision to make the versions. Let's pop it into a new code interpreter chat quickly. save it as a frame prediction. Some errors in it as well. Some explanation for it. Great. Question is, can I change this to, can I change this Python script to HTML with JavaScript? See what it says. Anyway, I'll be having trouble running this on Linux because I don't have everything installed. Wait, let's move back to Windows.
You can recreate the functionality of this Python script in a web-based environment using HTML and JavaScript, but there are several challenges and steps involved. Frontend, HTML/JavaScript. Use HTML canvas to display the moving circle and the predicted frames. Implement the circle movement logic in JavaScript. This would replicate the behavior of the generate_data_with_circle function. Use web libraries like TensorFlow.js to build and run the neural network model directly in the browser. Backend, optional. If you decide not to run the model directly in the browser, you could set up a backend service using Flask, Django, Express.js, etc. that takes a sequence of frames as input and returns the predicted sequence. This backend would use TensorFlow or Keras to make predictions. The frontend would then communicate with this backend using AJAX calls. Model conversion. If you're using TensorFlow.js on the frontend, you'll need to convert your Keras model to the TensorFlow.js format using TensorFlow_converter. If you decide not to run the model directly in the browser, you could set up a backend service using Flask, Django, Express.js, etc. that takes a sequence of frames as input and returns the predicted sequence. This backend would use TensorFlow or Keras to make predictions. The frontend would then communicate with this backend using AJAX calls. Model conversion. If you're using TensorFlow.js on the frontend, you'll need to convert your Keras model to the TensorFlow.js format using TensorFlow_converter. Real-time predictions. Model conversion. If you're using TensorFlow.js on the frontend, you'll need to convert your Keras model to the TensorFlow.js format using TensorFlow_converter. Real-time predictions. If running the model directly in the browser, use TensorFlow.js to make predictions in real time and update the canvas accordingly. If using a backend, send the sequence to the backend and get the predicted frame, then update the canvas. Here's a very simplified outline of how this might look. HTML. HTML. Copy code. Moving circle prediction / type. JavaScript, script. Load the model, assuming you've converted it for TensorFlow.js, let model. Implement the circle movement and drawing logic, // for predictions, function predict next frame, sequence, if, model, const. Extract the frame and draw it on the canvas, // set an interval to update the canvas regularly set interval, equals, // update the sequence and. Remember, this is a simplified version, and the actual implementation would be more involved. You'll need to handle various aspects like data preprocessing, sequence updating, model predictions, and efficient canvas rendering.
Obviously, that would not continue. Obviously, that would not do anything useful. Rename this into image prediction. We're not calling that yet.
Continuing from where we left off, let's delve deeper into the individual components of the web-based version. 1. Circle movement and drawing logic. For simplicity, we can create a circle object with its properties and functions to move and draw. JavaScript.
Python. Some sort of cache file. What? The cache file. This script.js. We have script.js. Delete that one. So we have this object, motion and drawing. This could be in the same JavaScript file.
This would be a bit more intricate. For this example, let's assume we're storing the last 4 frames in a sequence and we want to predict the next frame. As previously mentioned, you can use setInterval to continuously update the canvas. Performance. Running predictions in real time directly in the browser might be CPU/GPU intensive. Ensure that the experience is smooth and consider adding optimizations if necessary. TensorFlow.js version. Ensure you're using the appropriate version of TensorFlow.js that matches the version of TensorFlow/Keras you use for training. Model size. Neural networks can be large, leading to slower loading times for the web page. Consider model optimization or pruning to reduce its size if needed. Preprocessing and postprocessing. Ensure that any preprocessing, like normalization and postprocessing you did in the Python code is also replicated in JavaScript. Model conversion. Remember to convert the model from Keras to TensorFlow.js format using the TensorFlow_converter tool. Fallbacks. Not all browsers or devices may support TensorFlow.js or web-based GPU acceleration. Consider implementing fallbacks or alerts for unsupported devices. Incorporating these details should get you closer to a functional web-based implementation of your moving circle prediction application.
Continue and update and generate the whole code with no missing bits. Get something working. So we'll need a HTML file. Continue and generate the whole code with HTML, CSS, and JavaScript without missing bits. Don't have the HTML yet. Already have that. Right, that's the one that wasn't actually doing anything. So we can get rid of this code. It's just loading the scripts. Yeah, the body in CSS we don't really need it because we're normally using the one from the whole website, from the whole Bionic Chaos website. This has this circle object, date canvas, predict next frame. I'll copy this JavaScript. Let's read that.
Model path. Replace path/to/your/model.json with the correct path to your converted TensorFlow.js model. TensorFlow.js version. Ensure you're using the appropriate version of TensorFlow.js. Model preprocessing. The code normalizes the pixel values to 0, 1 range before feeding them into the model. Ensure that this matches the preprocessing steps you used during training in Python. Performance. Running this in real time in the browser may be performance intensive. Consider optimizing if needed. Model conversion. Remember to convert your Keras model to TensorFlow.js format using the TensorFlow_converter tool. Save each of the above blocks into their respective files, index.html, styles.css, and script.js. When you open the index.html in a browser, it should display the moving circle and attempt to predict its next frames using the model. Regenerate. Chat. Remember to convert your Keras model to TensorFlow.js format using the TensorFlow_converter tool.
Just generating an empty box. I don't know, can you see any circles? No. The HTML is generating empty black box, no moving circles. Right, we don't have the model. The model. Why am I not getting an error message? There should be an error message. No, I don't see any.
Let's troubleshoot and rectify the situation. Model path. First and foremost, ensure that the model path in the JavaScript code, path/to/your/model.json, is correctly pointing to your converted TensorFlow.js model. Console errors. Open the browser's developer console, Control+Shift+I or CMD+Option+I on Mac, to see if there are any JavaScript errors or warnings that might give us clues. Debugging the JavaScript. Check if the model is being loaded. Add a console.log model loaded inside the .then block after the model has been loaded.
Yeah, we need to do this. And
The update canvas function is being called by adding a console.log updating canvas at the beginning of the update canvas function. Ensure TensorFlow.js support. Some older browsers or configurations might not support TensorFlow.js. Make sure you're using a modern browser like the latest versions of Chrome, Firefox, or Edge. Adjustment to circle initialization. The circle might be initialized at the edge of the canvas, causing it to get stuck. To avoid this, we can adjust the initialization to ensure it starts more towards the center.
Yeah, no errors, no circle. Have the info txt. Right, it's actually there. There's no link to it, so it's unlisted, so it should be probably removed. Let me check if the EEG tool in the same. Right, we do have EEG data processing. Yeah, obviously, this one won't be possible to turn this into HTML and JavaScript, would it? Maybe it will. It's only 100 lines of code. We're getting stuck with the previous tool, so I'm just move on to the EEG stuff.
This script demonstrates a complete pipeline for EEG/MEG data analysis, starting from raw data visualization and preprocessing to feature extraction and classification using a support vector machine, SVM. I'll break down the process for you. Data loading and visualization. Load MNE sample data. Visualize the raw MEG data for a short duration. Preprocessing. Detect events based on stimulus channels. Apply a bandpass filter to the raw data to retain frequencies between 0.1 Hz and 50 Hz. Segment the continuous data around event onsets, epoching, for two types of auditory stimuli, left and right. Any epochs with excessive EEG artifacts, greater than 100 V, are discarded. Power spectral density, PSD, visualization. Plot the average PSD across all epochs. Feature extraction. Calculate the PSD for each epoch using the multi-taper method. Extract frequency band powers, delta, theta, alpha, beta, gamma, for each epoch using the trapezoidal rule for numerical integration. This results in a feature vector for each epoch. Band power topographic maps. Visualize the spatial distribution of power across the scalp for each frequency band. Label extraction. Extract corresponding labels for each epoch, 1 for auditory/left and 2 for auditory/right. Feature standardization. Use standard scalar to standardize features so they have zero mean and unit variance. This step is crucial for many machine learning algorithms, including SVM. SVM classification. Use grid search CV to find the best parameters for an SVM classifier using 5-fold cross-validation. In this case, it's searching over different values of C, regularization parameter, and kernel types. If the best kernel is linear, it visualizes the SVM weights for each frequency band to provide an understanding of which bands are more informative for classification. From this script, you can gather insights about which frequency bands, example alpha, beta, etc., are most relevant in distinguishing between the left and right auditory stimuli based on the SVM weights. If one band's weight is significantly higher, it indicates that this band plays a crucial role in the classification decision. One thing to note is that the accuracy reported is based on cross-validation and not on a separate test dataset. For a more accurate evaluation, you would ideally split the data into a training test set and evaluate the model's performance on the unseen test set.
but there was a split point two. No, that's something else. Is it possible? Is it possible to turn this Python script into JavaScript and HTML?
Yes, it's possible to convert Python scripts into JavaScript and HTML, but with some caveats. The pipeline you've shown is heavily dependent on Python-specific libraries such as MNE, NumPy, scikit-learn, and matplotlib. These libraries don't have direct equivalents in JavaScript. To achieve a similar pipeline in a web context using JavaScript and HTML, you need to take a few steps. Replace libraries. Identify JavaScript-based libraries that can replicate the functionality of the Python libraries you're using. For instance, you might consider using TensorFlow.js for some of the machine learning parts. For plotting, libraries like D3.js or Plotly.js might be suitable. Data handling. If you're processing large datasets, browser-based JavaScript might not be the best choice due to memory and performance constraints. In this case, you could set up a backend server, example, using Flask or Django in Python, that processes the data and sends the results to the frontend for visualization. Rewrite the code. Once you've settled on the appropriate JavaScript libraries, rewrite the Python code in JavaScript. This step will involve re-implementing the pipeline, not just translating Python to JavaScript. Once you've settled on the appropriate JavaScript libraries, rewrite the Python code in JavaScript. This step will involve re-implementing the pipeline, not just translating Python to JavaScript. Visualization with HTML/CSS. Create an HTML/CSS frontend that takes user input, interacts with the backend if needed, and visualizes the results using the chosen JavaScript libraries. Deploy. Once you've developed the frontend and backend, deploy them. The backend can be hosted on platforms like Heroku, AWS, or DigitalOcean. The frontend can be hosted on any web server or platforms like Netlify or Vercel. Here's a very simplified and high-level example to give you an idea. HTML. Remember, this is a very high-level overview.
Yeah, it is a too high level and not getting anything out of this except the suggestion for using a backend for data handling. It's probably a better option.
Tasks that are computationally heavy or involve processing large datasets, it's often a good idea to offload the work to a backend server. The browser is not designed to handle intensive computations, especially with large datasets, due to memory and performance limitations. Here's a basic approach for integrating a Python backend, using Flask, for instance, with a frontend. 1. Set up a Flask backend. You can create a Flask server that accepts data, processes it using your pipeline, and then sends back the results. You can then create a frontend that allows users to upload or input data, sends this data to the Flask backend for processing, and then displays the results. You can deploy the Flask app to platforms such as Heroku, AWS Elastic Beanstalk, Google Cloud, or DigitalOcean. The frontend, depending on its complexity, can be hosted on any web hosting platform or even on the same server as the backend. This setup ensures that the intensive processing is done on the server, which is equipped to handle it, while the browser focuses on presenting the data and providing a user interface.
Can I host on Windows 11 IIS?
You can host a Flask application on Windows 11 using the Internet Information Services (IIS) web server. However, IIS is traditionally used for hosting .NET applications, so hosting a Flask app requires some additional setup using the FastCGI protocol and a tool called FastG. Here's a step-by-step guide to host a Flask application on IIS in Windows 11. 1. Install IIS. Open Control Panel Programs and Features, turn Windows features on or off. Check Internet Information Services and install it. After installation, you can access the IIS Manager by searching for IIS in the Start menu. 2. Install Python. Make sure Python is installed and added to the path. You can check this by running. Enables IIS to run Python applications via FastCGI. Install it using pip. Bash. Copy code. Pip install. Our Flask app's entry point, example app.py, ensure the app runs with the following.
Don't get it, why? And I use Python code without Flask that writes a JSON file and then loads it into HTML. Oh, so that code actually working okay. Training is not doing much there. There's not much reduction in the loss function. Doesn't mean don't need that many epochs.
You're looking for a simpler approach without setting up a full-fledged web server like Flask. You can use a Python script to process the data, write the results to a JSON file, and then use HTML and JavaScript to read and display the content of that JSON file. Here's a basic outline of this approach. 1. Python script. Write a Python script that processes your data and writes the results to a JSON file. You can then create an HTML file with embedded JavaScript to read and display the content of the JSON file. HTML. Run the Python script to process the data and generate the results.json file. Open the HTML file in a web browser to see the results. Considerations. Data freshness. If the data changes often and you want the HTML to always display the most recent results, you'll need to rerun the Python script each time before opening the HTML file. Security. This approach is suitable for local use or controlled environments. If you decide to host the HTML and JSON on a public server, be cautious about the data you're sharing, especially if it's sensitive. Automation. If you want to automate the process, you can set up scheduled tasks, example, using Windows Task Scheduler, to periodically run the Python script and update the results.json file. This approach is a simple way to visualize data processed by Python without setting up a web server or a complex web application.
And I run the Python script on request from HTML.
Yes, you can execute a Python script from an HTML page, but it requires some form of server-side execution to trigger the Python script. HTML by itself cannot run a Python script because HTML is a markup language and doesn't have the capability to execute server-side scripts. Here's a simple way to accomplish this using Flask, which will serve the HTML and also handle the server-side request to run the Python script. 1. Flask application. Create a Flask application that serves an HTML page and runs the Python script upon request. Create an index.html in a folder named templates. This is the default folder Flask looks for templates. HTML. Copy code. Start the Flask application. Navigate to http://localhost 5000/ in your web browser. Click the Run Python script button. This will execute the Python script on the server side, and the results will be displayed in the HTML page. This approach allows you to run a Python script upon request from an HTML page and display the results in the same page. It's a simple way to integrate server-side Python execution with client-side HTML/JavaScript.
And the Flask application run continuously non-stop.
Yes, a Flask application can run continuously non-stop. However, the built-in Flask development server is not meant for production use. It's designed for development purposes, and while it can run indefinitely, it's not optimized for performance, reliability, or security in a production environment. For a production deployment, you would typically run the Flask application behind a production-ready web server. Some commonly used options include Unicorn, a popular WSGI HTTP server for Unix. It's lightweight, easy to set up, and works well with Flask. UWSGI, a full web server and application server container. It's more complex than Unicorn but offers a broader set of features. Jinx or Apache with mod_whiskey. These are full-fledged web servers that can also serve as reverse proxies for your Flask application. They can handle client connections and pass requests to your Flask application through a WSGI interface. When using these servers, you can set your Flask application to run as a service, ensuring it starts on boot and can recover from crashes. This setup will allow your Flask application to run continuously and non-stop. Steps to ensure continuous running. Use a process manager. Tools like systemd for Linux or Windows Services for Windows can be used to manage your Flask application, ensuring it starts on boot and restarts if it crashes. Monitor the application. Tools like Monit or Supervisor can monitor your Flask app and restart it if it stops unexpectedly. Regular backups. Ensure regular backups of your application data to prevent data loss in case of failures. Logging. Implement comprehensive logging to track and diagnose any issues that arise. Updates and maintenance. Regularly update your application and its dependencies to benefit from.
Last time I was running, it wasn't running for this long. I don't know what's up. It'll be the last epoch. Yes, the problem. If M&E. For some reason I don't want to use. Don't want to use Flask for some reason. But Django is Python based.
It seems like you're comparing Flask to another web framework or tool, but the name of the other framework or tool is missing. Flask is often compared to many other web frameworks due to its popularity and simplicity. Some common comparisons include Flask versus Django. Django is a high-level web framework for Python that includes an ORM, an admin interface, and many built-in features. Flask, on the other hand, is more minimalistic and micro, giving developers the flexibility to choose their components. Flask versus Express. Express is a minimalistic web framework for Node.js, similar in philosophy to Flask but for the JavaScript ecosystem. Flask versus FastAPI. FastAPI is a modern web framework for building APIs with Python based on standard Python type hints. It's known for its performance and easy-to-use syntax. Flask versus Tornado. Tornado is a Python web framework and asynchronous networking library, primarily designed for handling long-lived network connections. Flask versus Bottle. Bottle is another micro web framework.
And on this bit.
Flask and Django are two of the most popular web frameworks in the Python ecosystem, but they cater to different needs and development philosophies. Here's a detailed comparison between Flask and Django. 1. Philosophy. Flask is considered a micro framework. This doesn't mean it's only suitable for small applications. Instead, it means Flask is minimalistic and modular by design. It provides the essentials to get an application up and running, but beyond that, developers have the flexibility to choose how they want to implement things. Django follows the batteries included philosophy. It provides a wide array of built-in tools and features, aiming to give developers everything they might need to build a web application without requiring multiple third-party packages. 2. Learning curve. Flask, due to its simplicity and minimalistic nature, Flask generally has a lower learning curve. It's a great choice for beginners who are just getting into web development with Python. Django has a steeper learning curve because of its many built-in features. However, once you grasp its conventions and the Django way of doing things, development can be very efficient. 3. Flexibility. Flask offers more flexibility as it doesn't impose a specific way to set things up. You can choose the components you prefer, such as which ORM or database to use. Django is more opinionated. It comes with its ORM and follows a specific project structure. This can be beneficial as it enforces best practices, but it may feel restrictive to some developers. 4. Built-in features. Flask comes with a basic set of tools to get a simple app running. Most advanced features, like database integration, user authentication, etc., require third-party extensions. Django provides a vast number of built-in features, including an ORM, an admin interface, authentication, and more. This can speed up development significantly since many common features are already integrated. 5. Extensions and plugins. Flask. There are numerous extensions available for Flask that add various functionalities, from database integrations to authentication systems. Django has a rich ecosystem of apps, plugins, that can be integrated into a project. The Django packages website lists a plethora of reusable apps for various purposes. 6. Use cases. Flask, well suited for smaller applications, prototyping, microservices, or when you need more flexibility in choosing components. Django, ideal for larger applications or when you want a framework that handles a lot of the functionality for you. Commonly used for content management systems, e-commerce sites, and other data-driven applications. 7. Community and documentation. Both Flask and Django have strong communities and excellent documentation. This means it's generally easy to find solutions to common problems, tutorials, and best practices for both frameworks. Conclusion. The choice between Flask and Django often boils down to the specific needs of a project and the preferences of the developer or team. If you value flexibility, minimalism, and choice, Flask might be the way to go. If you're looking for a robust, all-in-one solution with many built-in features, Django could be the better choice. Regenerate. ChatGPT may produce inaccurate information about people, places, or facts. ChatGPT August 3rd version.
And sure, we can reduce the number of epochs for this training. It takes forever. Yeah, we're using quite a few resources. It's not great. Like 50% CPU, 60% GPU, but that's probably for the live streaming. Yeah, that code is, it's loading something now. The dataset is too large. The code is too complicated. The user interface is not great. That's using that many. It's loading now. Sorry, overall, the main problem is just too slow. Now the training finished. Yeah, you could definitely stop it earlier. Right, I'm not getting anything useful for this particular example. The weight values are all zero there. and it's hard to rearrange. Ideally, it will be all in like all in one screen. Remember which way we tried arranging it before? It was something like this. Yeah, so ideally we'll have a tool displaying it as such. So we want to really like a tool like this. Still have to, this dataset is a bit confusing. Still haven't figured out what the data actually is and why there's so many stimulation channels, and why this one that is actually being used for the SVM weights is not just binary like 0 and 1 like what this seems to be. Why do you have other levels in there? Meant to be stimulation on the left and right side of the head. I don't think this code is actually correct in terms of what it does. Have to double check everything. Or ideally, get the code interpreter to double check this. We loaded this code. Um, Give us a description of it. Yeah, this was a wrong question. Well, we can edit it from there. Yeah, because I was asking to convert it entirely, and yes, so for example, M&E would not have JavaScript modules, not the entire pipeline. Possible to add JavaScript and HTML for visualizing.
Code interpreter. Import numpy as np import mne from mne.time_frequency. Integrate JavaScript and HTML for visualization purposes in many contexts, especially in web-based applications. For instance, if you're building an interactive web dashboard to visualize EEG/MEG data, you can use tools like d3.js, chart.js, Plotly, or any other JavaScript visualization libraries in conjunction with HTML and CSS. Here's a high-level idea of how to integrate. Setup. Create an HTML page to host your visualizations. Include the necessary JavaScript libraries, either via CDN or locally. HTML structure. Design the layout using HTML tags. For instance, you might have different div elements to host different visualizations. JavaScript. Use JavaScript to fetch your data. This could be from a local source, or you might make AJAX calls to an API endpoint. Use the chosen visualization library's API to bind your data to visual elements and render them. Interactive features. Enhance the visualization with interactivity. For instance, you can add zooming, panning, tooltips, etc. Here's a simple example using d3.js.
So this is ND. It's creating like an image element, is it? No, it doesn't look like.
This example, we've created a simple bar chart using d3.js to visualize the power of different frequency bands. For EEG/MEG data visualization in a web context, the process becomes more complex, especially if you want to visualize raw signals, spectrograms, or other complex data types. You'd likely need additional tools or libraries tailored for the specific type of data visualization you're aiming for.
Would this just work? Where is it getting the data from? No, it's just faking the data. Um, yeah, this using this FIF file. Continue with using real data from the Python script.
The task here is to visualize the frequency band powers derived from the EEG/MEG data in the Python script in an interactive web-based context. For this, we'll extract the data in a format that can be consumed by JavaScript. Create an HTML page with embedded JavaScript to visualize the data using a library like d3.js. Let's start with the first step. Step 1. Extract data from Python script. Before we can visualize data in an HTML context, we need to have it in a format that JavaScript can understand, such as JSON. You have computed the band powers for each epoch in the variable feature_list, which contains power values for the bands delta, theta, alpha, beta, and gamma. Let's convert this data to JSON format.
Yep, that's exactly what I want. That feature the variable names. Look a bit weird. So we don't want to plot here. We want to export bands, feature names. I'll just take that variable there. Should work. Can get rid of the plotting or leave it for now.
You can save this JSON underscore data to a file, or if you're integrating this with a web server, send it as a response to an API request. Step 2. Create an HTML page with embedded JavaScript. Here's a basic example using d3.js.
Uh, what's this one? I don't remember this. It's not doing anything. It's just such could be used as a template. Yep, that's a good template. Okay, it's the why is it not giving me the script? Should be straightforward. Just taking the JSON file. Hopefully this will be generated in the same folder, and then we load it into the HTML. What do we have all this? Stuff is not working anyway. Should be giving, yeah, it's giving about 10 errors to be expected, because don't actually need all that. Okay, let's start a new one. This HTML is not complete. Can you update the HTML and complete the whole script without missing bits? Be a style CSS file in this folder as well. Might as well edit straight away. Can leave this header. And get rid of that. It keeps putting a placeholder for the JSON data. Yeah, this is getting ridiculous. Didn't give me there. Where's the CSS? Should be, it's just in the same file. Right, well, we have that, that's fine, but that's not really what I wanted. We want to actually take the data from this JSON file. By the way, what? No, wait. Ah, it's good because the second time we didn't do the training. It's meant to save the model, the trained model. Don't think it did. Right, we need to run it again so it generates the JSON file that then we can load into HTML, essentially because we don't like the current user interface. Using some legacy functions. That's no good. It's loading the charts. Didn't do the training again, which is good. Means it actually remembered that. And yeah, we have the data, which is on a different screen. And we should have the JSON file as well, but I guess I'll only get it after closing. Um, so I have to close those. You'll have one. Yeah. Now it should have saved. Should have written a JSON file, but I don't see it. That's unfortunate. Isn't this already a file? Where is the JSON file being saved or dumped? It keeps giving me the HTML either with, well, that's meant to be JavaScript, either with fake data or no data at all. Yeah, yeah, that's right.
My apologies for the oversight. I provided the process to convert the data to JSON format in a Python script but didn't explicitly mention saving it to a file. Here's how you can save the JSON_data to a file in Python.
Right, so we need this.
After running the above code, you'll have a file named EEG_band_powers.json in the directory from where you executed your script. This file contains the frequency band powers in JSON format. For the HTML visualization to access this file, you'll need to either place the EEG_band_powers.json in the same directory as your HTML file and then fetch it using JavaScript. Use an absolute path or a web URL to fetch the JSON data in your JavaScript code if the file is hosted somewhere else.
Oh, it's option 1. Thank you for giving me options, easy options. Yeah, I'm running that script again. Hopefully by the end of it we'll have a JSON file in the same folder that we could load by the HTML.
Here's how you can modify the HTML file to fetch the EEG_band_powers.json using d3.js and then visualize the data.
It's not what the JPEG. I know that is the name of the file, so it's generating those images again. Probably have to remove all the plot functions. It's the 7 times. Yeah, that one is. Good. Oh, it's always writing into a main folder, so it's not in the right folder. I already had this problem before. Don't remember how it got resolved, but essentially I can copy it for now. So I have it here. It's a JSON file. Some fake data. No, it doesn't look fake. It looks real. Like 10 numbers after the decimal point, but that's not what I expected. Now the HTML should be, it's okay, dark orange, whatever. Script fetch the JSON. Yeah, that looks better. Doesn't look. Do I have any missing bits, which is good? Right, that's supposedly the real data. I don't know what the color is only changing when you hover over it. Doesn't actually do anything when you're clicking on or anything. So not extremely useful, but just need to check if it's the real data or not. By the way, that's the previous tool that we had running. Behaving in a bit of a weird fashion, but simulation of particle motion. So basic model. There's all the mathematical equations and everything for this model are available. You can play around with it, see, tell me what you think. Yes, every time you resize the screen or something, it starts over. Just something to be aware of. It's another tool that we were trying to create earlier today. It didn't quite work, as you can see. It's not actually doing anything. And we have this new one that displays, so essentially a simplified version of M&E review tools. This is EEG. There's a lot of data in there. I'm trying to simplify it. Supposedly this is real. So those are your EEG bands. And hopefully they're actually real, like taken from an actual file.
Breakdown of the changes. We utilize the d3.json function to asynchronously fetch the JSON data from the EEG_band_powers.json file. The .then function data part ensures that once the data is fetched, it's passed to the function to create the visualization. The visualization steps within the function remain largely the same as before. The difference is that the data is fetched from the JSON file rather than being hard-coded into the script. Once you have both the HTML file and the EEG underscore band underscore powers.json in the same directory, opening the HTML file in a browser will display the bar chart using the data from the JSON file.
Yeah, that's right. And in the Python script, so we can get rid of the visualization. Now the question is, if you want to change any, say the change any of these parameters, can we rerun the Python script without using anything fancy like was it Django, or the other one? Yeah, I'm getting confused with all the names, but you know the one, Flask. Yeah, that's the one. Just have something simpler than that. So let's just trace this data back. We have these bands. Data to export. Average band power. Right, so we want to display not just the mean, but the error margins as well. That would be handy. And we want to remove any visualizations from the Python script. Want to make our own. Ideally, we want to replace this M&E as well, so we want to do everything from scratch. So we just want to take the raw data and manipulate it ourselves. And let's copy this quickly. It will give us an explanation as well.
The Python script you provided does the following. Loads and preprocesses the M&E sample EEG/MEG data. Visualizes the raw data. Computes and visualizes the power spectral density, PSD, of the epochs. Extracts features in the form of band powers for different frequency bands. Visualizes topographies for specific bands. Extracts labels for the epochs. Standardizes the features. Trains an SVM classifier using grid search CV. Visualizes the SVM results if the kernel is linear. Converts the average band powers to JSON format. Saves this JSON data to a file named EEG underscore band underscore powers.json. By the end of this script, you'll have a file named EEG underscore band underscore powers.json in the directory from where you executed your script. By the end of this script, you'll have a file named EEG underscore band underscore powers.json in the directory from where you executed your script. This file contains the average band powers in JSON format. With this JSON file and the HTML code I provided earlier, you can visualize the EEG band powers in a web-based environment. Just make sure the HTML file and the EEG underscore band underscore powers.json file are in the same directory, and then opening the HTML file in a web browser will display the bar chart.
Yeah, that's right. So it's working okay. Want to display more details. And we want to also explore if we can actually change. So this Python script question is if we can have so can the HTML code or JavaScript call the Python script with different parameters.
You can use JavaScript in an HTML page to call a Python script, but this typically involves using a web framework or server to handle the communication between the frontend, HTML/JS, and the backend, Python script. Here's a general approach using Flask, a lightweight Python web framework.
The problem with Flask is that I already deploy in IIS. The problem with Flask is that I already deploy on Windows 11 using IIS. Yeah, I don't wanna.
Deploying Flask applications on IIS, Internet Information Services, on Windows is indeed a bit more involved, but it is definitely possible. Here's a step-by-step guide to help you integrate the Flask app with IIS on Windows.
Yeah, but I don't wanna do it. I want the Python script to generate files if I'm. It's like start a new chat, just default GPT-4. Can HTML code run a Python script? Or JavaScript, should be the same. No.
HTML by itself cannot run a Python script. HTML is a markup language designed for structuring and presenting content on the web. However, you can integrate Python scripts with HTML in various ways. Web frameworks. Using web frameworks like Django, Flask, Pyramid, etc., you can create web applications where HTML is used to render the frontend, while Python provides the backend logic. When certain actions occur on the HTML frontend, example, a form submission, Python code can be triggered on the server. Common Gateway Interface, CGI. This is an older method where a web server can directly run a Python script using CGI. When a user requests a certain URL, the server executes the associated Python script and returns its output as the HTTP response. Web APIs. Python can be used to create a web API, using frameworks like Flask, Fast API, etc., that communicates with the frontend using Ajax. Using JavaScript on the frontend, you can make asynchronous requests to the Python backend and update the HTML content dynamically based on the response. Embedding Python.
Yeah, that's not a bad option.
Create a web API, using frameworks like Flask, Fast API, etc., that communicates with the frontend using Ajax. Using JavaScript on the frontend, you can make asynchronous requests to the Python.
But why there's always another tool that needs to be the web API. So if my Python is writing into a JSON file, well, that's it. That's the that's the API.
Embedding Python in HTML using tools like Brython. Brython allows you to write browser-based applications in Python.
By the way, WebSockets is what I'm currently using with the National Instruments tools, but that's what I wanna move away from.
WebSockets. For real-time applications, you might use WebSockets to have an open communication line between the browser, HTML/JavaScript, and a Python server. Libraries like Socket.io, with Flask Socket.io for Python, can help achieve this. Remember that when you use methods like web frameworks, CGI, or web APIs, the Python code runs server-side. The client's browser only receives the resulting data, typically HTML, JavaScript, or JSON. Direct execution of Python on the client side would require tools like Brython or a Python plugin, but these are not standard and can introduce compatibility issues. If you're looking to integrate Python with a web page, starting with a micro framework like Flask is often a good choice due to its simplicity and flexibility.
Yeah, it's probably doable, but no. Yeah, web API. Provide more details on web APIs.
Web APIs, application programming interfaces, have become a fundamental building block for many modern web and mobile applications. They provide a way for applications to interact with one another, typically over the HTTP protocol. Here's a deeper dive into web APIs. Definition. A web API is a set of defined rules and protocols for building and interacting with software applications. It's a way to enable communication between different software systems over the internet. Why web APIs? Decoupling. APIs allow front-end and back-end systems to work independently. The front-end focuses on user experience while the back-end manages data and business logic. Is a set of defined rules and protocols for building and interacting with software applications. It's a way to enable communication between different software systems over the internet. Why web APIs? Decoupling. APIs allow front-end and back-end systems to work independently. The front-end focuses on user experience while the back-end manages data and business logic. Interoperability. APIs enable different software systems, often written in different programming languages or running on different platforms, to communicate with each other. Reusability. Once an API endpoint is developed, it can be used by multiple clients, be it web browsers, mobile apps, or other servers. Components. Endpoints. These are specific routes or URLs where API calls are targeted. Each endpoint corresponds to a specific function. HTTP methods. The standard methods include get, retrieve data. Post, submit data for processing or create a new record. Put/patch, update data. Delete, remove data. Request and response format. APIs often communicate using JSON or XML. The client sends a request in a specified format, and the server returns data in a similar format. Request and response format. APIs often communicate using JSON or XML. The client sends a request in a specified format, and the server returns data in a similar format. Status codes. HTTP status codes give information about the success or failure of the request. Examples include 200 OK, 404 not found, and 500 internal server error. Building a web API with Python. Python has several frameworks to build web APIs. Here are some popular ones. Flask. With Flask RESTful, a lightweight framework that's easy to get started with. Django. With Django REST framework, a more robust solution suitable for larger applications. Fast API, a modern, fast, high-performance web framework for building APIs based on Python 3.6 plus type annotations. Securing web APIs. Security is crucial.
More details on Fast API.
Good documentation is essential for any API. It provides developers with the information they need to use the API effectively. Tools like Swagger, with OpenAPI specification, can help generate interactive documentation. Versioning. It's a good practice to version your API. This ensures that when changes are made, existing clients don't break. This can be done using the URL, example, /v1/users, or request headers. In summary, web APIs serve as a bridge between different software systems, allowing them to communicate and share data. With Python's rich ecosystem, building and deploying scalable web APIs has become more accessible than ever. Regenerate. ChatGPT may produce inaccurate information about people, places. A good practice to version your API. This ensures that when changes are made, existing clients don't break. This can be. Web APIs serve as a bridge between different software systems, allowing them to communicate and share data. With Python's rich ecosystem, building and deploying scalable web APIs has become more accessible than ever.
Yeah, don't think I need any specific tool. All I want to do is regenerate this JSON file. If something changing in the HTML. So you want a button here. You want to say I want to look at a different channel, and it will just regenerate the data. Because the original data is in this weird FIF files, which is supposedly unique to M&E. Ideally, it will be a different type of file. Right, let's quickly get back to this ECG waveform simulation. This is synthetic data, so not actually taken from anywhere. The actual mathematical equations that they use to calculate this. Do want to change the name of the URL, however, to have underscores in the name there. EEG processing. I want to rename this as well. I think we're calling it from anywhere else. Yes, this would not work. Back. And the ECG visualization simulator, we also want to change the name. Call it simulator. So this will stop working. And it's meant to be a link in here, but we quickly need to change. Just run it there for a sec. Live server. One and image. Um, let's just separate for a sec. Yeah, it's not great. We need to. It's adjusting with the screen, which is good. But not scaling properly. wanted to scale properly with the screen. Right, this is better. There is explanation. I'd like to add spaces there. That's okay for now. At this we'll need the need the CSS. The JavaScript. It's the data. Again, it's a synthetic data. And if the screen is too wide, can the two charts be placed side by side instead of vertically?
Yes, you can place the two charts side by side when the screen is wide enough. One common approach is to use CSS media queries to adjust the layout based on the screen width. Here's a step-by-step guide. Wrap the charts in a container. Wrap both chart div elements in a parent container.
Both charts in the parent container. Arrays. We have a header. I think this can be replaced. These two bits.
Add some basic styles to make the charts take up the full width by default.
One take charts container take full width by default. default. We actually yes, we want that, but in the chart bit, we want to this. Right. This better.
Use a media query to change the layout for wider screens. Here, we'll use 768px as the breakpoint, but you can adjust it based on your design needs.
Probably should be more like 600.
With the above styles, when the screen is below 768 pixels wide, the charts will be stacked vertically. When the screen width is 768 pixels or wider, the charts will be side by side. Ensure Plotly adjusts to new sizes. Make sure that the Plotly plots are resized whenever the window is resized. It seems you already have this code in place, but just ensure it's working correctly after making these layout changes. Optional enhancements. You might want to add some padding or margin to the individual chart elements to ensure they have some spacing between them when side by side. Remember, the pixel values used above, like 768px, are just examples. Depending on the content and design of your website, you might want to adjust these to better fit your needs. The key concept is using media queries to adjust the layout based on screen width. Regenerate. ChatGPT may produce an
Yeah, that's much better. Thank you for that. I want to change the thumbnail for it. Change the thumbnail. Yeah, probably can be something like this. Do this quickly. Still have GIMP open, do I? Yes. I want that standard 720. To new layer. To scale this. Its size is okay. Crop. I wanna take crop some more. But take that color, make it our background. Right. Make it. No. Larger. Okay, this thing is all. This. I don't know. It was distorted. Yeah, it's not a great resolution, but that's okay. It will be just a temporary thing. Okay, this is taking too long already. Change the background for this thing. And this should do. I'll export it as an image as well. As JPEG, that's fine. Minimize that. Delete the data. Go there. Need to copy this. Okay, so we're actually removing this one. And changing order, I'm not sure. Plot the ECG. Right, so this image bionic images. Oh, come on. I'll pop it in there. I might just take it offline. So I'll just say bye bye for now and keep going until we get interrupted as per usual. Right, well, this could use a different background color. The previous one is not needed. Yes, images. Um, oh, yeah, this one is not needed anymore. And the actual thing would use a different background. And this color is actually meant to mean something. Those are ECG tools, those are EEG tools. So ECG tools should be that red. like a different color. That's okay. Before it just worked. No, doesn't. No, we don't want to edit this. Should be fine. Be a temporary thing anyway. I hope. Bought. Same name. Pop it in here. No, don't move. Copy, replace. Right. G waveform. And the link. The actual link was corrected. Into ECG, if you know. ECG simulator. Event underscore. Right. That's working. Yeah, the particle motion should have a different background. Should have some sort of generic background. We'll fix it later. So we got a bunch of new, not a bunch, just two. This one remains the same transcription and still working, hopefully, on some devices in some browsers. It's as good as it gets. We might do more, like if the transcription is working and get the speech rate and everything, we can improve on those metrics and how they're being displayed and add some more analytics to it. We have this particle motion that's working okay. It's behaving in a bit of a weird way, but don't bounce off each other, so they just get stuck to each other. Just another different type of simulation. They do bounce off the edges. Yeah, so that's just an example of what can be done in JavaScript, HTML. And we have the ECG waveform tool. These numbers have to be updated. The idea is that you can synthetically vary EEG parameters and then calculate the variability. That's for you to learn about the ECG waveforms and what can change in them. It's just a prototype still, and we will make it better next time. And we have a bunch more tools in the pipeline to come online soon. So see you next time. Bye.